Hello everyone. Today we will be taking the parallelogram law of vectors. And what is the parallelogram law of vectors? It states that if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram, a diagonal drawn from the point of intersection of the vector represents the resultant vector in both magnitude and direction. So let me very quickly explain it. Assuming we have two vectors now, let me call this one vector A and this is vector B. And they are inclined together at an angle alpha. So for us to find the resultant vector of this A and B, we can use the parallelogram law of vector. And how do we use it? We just turn it to a parallelogram. I know that the opposite sides are equal, so this will be equal to A here, and this will be equal to B here. And then the diagonal we draw from this place to this place, from here to here, is the resultant vector. So the diagonal we draw from here to here is the resultant vector. So that's why if you look at this statement, the diagonal drawn from the point of intersection of the vector represents the resultant vector in both magnitude and direction. It's very simple. Actually, you don't need to cram all this one. You don't need to cram all this one. You just need to understand the simple concept that the diagonal drawn from here to here will represent the resultant vector in both magnitude and direction. So let me quickly solve these two questions. And as I'm solving the question, I know you will have more comprehension of what I'm saying. And then, for us to use parallelogram law of vector to find the resultant force, because there's other method, we can use the triangle method. For us to use the parallelogram law of vector, first of all, we must have two vectors, and then they must not be inclined at angle 90. Or the vectors must not be perpendicular to each other. If they are perpendicular to each other, we cannot use the parallelogram law of vector. What we are going to use is the Pythagoras theorem. So that's why this number 1 and number 2 question, they are not perpendicular. Look at this one. This one is 60 degrees inclined to each other, and this one is 120 degrees inclined to the other one. So let me start with the first one. So we have two forces. They are inclined to each other at an angle of 60 degrees. So this 60 degree, angle of 60 degrees. So the first one is 7 Newton, and then the second one is 10 Newton. So assuming WAEC asks this kind of question, how are we going to go about it? It's very simple. What you just do is to turn this to a parallelogram. Turn this to a parallelogram like this. And then from the definition that I give, that the diagonal drawn from the point of intersection represents the resultant vector in both magnitude and direction. It represents the resultant vector in both magnitude and direction. So they are 60 degrees inclined to each other, which actually means that I said something that the opposite side of a parallelogram are equal. So if this one is 7 Newton, this one will also be definitely 7 Newton, and this one will be 10 Newton. So now let us quickly find the resultant. So what's the resultant that we are looking for? This line here. And then there is something that I usually do for simplicity's sake. What I usually do is that I will bring out this a triangle out. This one is 120. Now this one is 60 degrees. So 180 minus 60 gets 120 here. So let me bring out this triangle here out. Let me call this one A, B. Okay, let me write it like this. So I will bring A, B, C out now. So okay, this is angle alpha, and it is no longer 60. It is alpha, and this one is 120 degrees. This is 7 Newton, and this is 10 Newton. So I am looking for this side. I am looking for this. I am looking for this side. So how do I go about it? The best method and the correct way for us to go about this now is to use the cosine rule. And what's the cosine rule? Assuming that we have a triangle like this, A, B, C. So this is B, small letter B, and this is small letter C, and this is small letter A. So according to the cosine rule, I hope you are seeing it. A square is equal to B square plus C square minus 2BC equals A. And B square is equal to C square plus A square minus 2AC equals B. And C square is equal to A square plus B square minus 2AB equals C. So using the cosine rule, I will use it to solve this equation now. So according to that diagram, so this is my small letter A, and this is C, and this is B. So this is what I am looking for now. So I'll just use A square is equal to B square plus C square minus 2BC equals A. So what's my B? B is 10 Newton. That is 10 square plus 7 square minus 2 7 cos 120. So 10 times, okay, 10 square will give us 100. 10 square will give us 100. And 7 square will give us 49. Give us 49. 2 times 10, that's 20. 20 times 7, that is 140. So we have 140 cos 120. And normally this cos 120 will give us a negative calculation, to give us a negative figure. So let's quickly check our calculator. Press our calculator 140 cos 120. If you press 140 cos 120, you are going to get minus 49. So minus 49 minus, I'm sorry, it is 70. You are going to get 70, not 40. So minus 149 minus 70, which you now will have 149 plus 70. So what is 149 plus 70? 149 plus 70 will give us 219. To 219. And if you not forget, all this one, it is A square. A square. So A square is equal to 219. So A will now be the square root of 219. And what's the square root of 219? If we press our calculator, we are going to get 14.8 Newton. 14.8 Newton. So that's our resultant vector in magnitude. But we are actually not true. We have gotten the magnitude of this resultant vector as 14.8. It still remains something. What we have, you know that vector quantity, it has both magnitude and direction. That is how vector is different from scalar. Scalar just have magnitude and no direction. But vector quantity has both magnitude and direction. So how do we go about it now? So let us quickly do this one. So we've gotten the magnitude of the resultant vector as 14.8 Newton. So the next thing for us is to find this angle. And how do we go about finding this angle? Very simple. We are going to use the sine rule. The sine rule states that A over sine A is equal to B over sine B is equal to C over sine C. So that's this sine rule. A over sine A is equal to B over sine B is equal to C over sine C. So, but this one we are looking for this angle here. So we can just write A over sine A is equal to C over sine C. So what's our A? Our A is 14.8 over sine 120. So what's our C? C is 7 over sine alpha. So if we cross multiply, let us cross multiply. We are going to get 14.8 times sine alpha is equal to 7 times sine 120. So sine alpha will now be equal to 7 times sine 120 divided by 14.8. So let's quickly press our calculator. That is 7 times sine 120 over 14.8. And the answer is 0.4096. 0.4096. So our sine alpha is equal to 0.4096, right? Not 7. So these are sine alpha. The next thing is for us to find alpha. So alpha will now be arc sine 0.496. 4096. So if you press the calculator, arc sine 0.4096, we are going to get 24.18. 24.18 degree. So the resultant vector is 14.8 Newton and the direction is 14.8 Newton as the magnitude, and this is the direction. You know that I'm saying that we work with vector quantity. When we are working with vector quantity, you don't just find the magnitude, you also find direction. Just like this year NECO physics question. I think maybe that number 2 or number 3 question in the theory, in the section A. There was a question there and a lot of people were just finding just the magnitude. Apart from finding the magnitude, you have to find the direction also. It's very simple. Once you just know the principle of the cosine rule, the sine rule, and the parallelogram law of vectors, don't forget that the diagonal drawn from the point of intersection represent the resultant vector in both magnitude and direction. So that's number one. This is the answer for number one, this and this. Let's quickly do the second one. So the second one, we were given a diagram. We are given a diagram. And this second one is actually NECO 2002 past question. It's a NECO question. So we have to find the resultant. So how are we going to do it? Turn it to a parallelogram. Okay. I think this one is 100 Newton. And this one is 80 Newton. So what are we going to do? Very simple. We'll convert it to a parallelogram. So just put it like this. And it will turn like this because the line that is here, the measurement of the line that must be here must be equal to the line that must be here. And I said that the opposite sides are equal. So the line drawn from here to here is the resultant vector. So these are resultant vector. And if this one is 120 degree like this one will be 60. So let us do it as we did the other one. I'm going to take the triangle outside. I'm going to take the triangle outside. I love it like that. So that when I'm teaching my students is more convenient. It's not like for me, but it's more convenient for them. So let's take the triangle outside. So this is 80 Newton, and this is that opposite side will be equal, and this is 100 Newton. So let's use the cosine rule. Cosine rule. So this is A, B, C. Opposite, that very small letter A, opposite small letter B, opposite of this one, small letter C. So that A square is equal to B square plus C square minus 2BC equals 60. So what's our B square? Our B square is 80 square plus 100 square minus 80 100 cos 60. So 80 times 80, that will give us 6,400. While 100 times 100 will give us 10,000. 1 times 100 is 10,000. So this one, 80 times 100 will give us 8,000. So 8,000 times 2 will give us 16,000. 16,000. And cos 60, if you press the calculator, you see that cos 60 is 0.5. Press your calculator, you see that cos 60 is 0.5. So this is 16,400. So 16,000 times 0.5 will give us 8,000. So 16,400 minus 8,000. Let's quickly press and calculate for that. So it is 8,400. 8,400. So A square is equal to 8,400. And if A square is equal to 8,400, so the square root of 8,400, and that is 91.65 Newton. So this is our resultant vector. The resultant of this force is 91.65 Newton. So the resultant of this force here is 91.65 Newton. So the next thing for us is to find the direction. And what's the direction? This direction here, the alpha. So we can just use the sign that would be the previous one, that A over sine A is equal to C over sine C. So what was our A? We've gotten our A here as 91.65. So we just put 91.65 over sine A. Sine A is 60 over sine 60 is equal to C is 100. C is 100, and this is sine alpha. So let's make sine alpha as the formula. That is sine alpha times 91.6 is equal to 100 times sine 60. So sine alpha will be equal to 100 times sine 60 over 91.65. So what will sine alpha equals to? Press your calculator. If you press your calculator, you are going to get 0. Sine alpha is 0.9449. So sine alpha is equal to 0.9449. And if sine alpha is 0.449, so alpha will now be arc sine 0.9449. So press your calculator for that too. And then the answer is 70.89 degrees. So the resultant of this vector, the magnitude is 91.65 Newton, and the direction is 70.89 degrees. So I hope you understand the parallelogram law of vector. We use it to find the resultant of two vectors, provided that they are not perpendicular to each other. If they are perpendicular, use the Pythagoras theorem. So let us go over this video again. Don't let us forget to like and subscribe. You should also share too. Let your friend know what is going on here. And by the grace of God, tomorrow we will continue on our mathematics. Have a nice day.